All right, 6.4, day one, we get into factoring polynomials. A lot of this stuff is going to look like review because we have covered it, but it's something that I know people don't always remember that well. So we're going to review the stuff we have covered, and we're going to talk about some new methods for factoring. So if we zoom in, the first one is GCF. So the GCF stands for greatest common factor, and it means what can you divide every term by. So if you look, we have 6 and 21. We can divide 6 and 21 both by 3. And then how many x's can you take away from each? So like, what is the most number of x's that you can, so you take the same number from each term. So the first one has x to the third, the second one is x to the fifth. So we can actually take away x to the third from both of these. So the GCF goes in the front, 3x to the third. And then in parentheses, we'll put the leftovers. So 6 divided by 3 is 2. And x to the third, we took away an x to the third, so there's nothing left in this term. 21 divided by 3 is 7. And if we have x to the fifth and you took away x to the third, we're left with x squared. So it's 3x to the third times 2 minus 7x squared. There's GCF. The second one is difference of squares. And by the way, you can use your factoring chart for all of these. You should have that. And on the top it says GCF, and then when you go down to the middle section in your factoring chart, it says when there's two terms, and in this case there's two terms, we do what's called difference of squares. So you'll see that 25 and 49 are both perfect squares. So difference of squares, there's two sets of parentheses. You take the square root of each term. So the square root of 25m squared is 5m, and the square root of 49 is 7. So you take the square root of both, and then you put in the parentheses. So 5m comes first in the parentheses, 7 comes second in the parentheses, and there's a plus sign and a minus sign. So plus and a minus. Perfect square trinomial is a trinomial, so 3 terms, and the first and the last term are perfect squares. So when you factor this, you end up getting, if we think about how we factor, 2 parentheses, what multiplies to w squared, w times w, and what multiplies to 121, 11 times 11. And both of these are plus signs. So w plus 11 times w plus 11. And what makes this special is that we can write this as w plus 11 squared. Okay. The next one is smiley face. We have a trinomial, and they're not perfect squares, so we go to 2 sets of parentheses. What multiplies to x squared? X times x. What multiplies to 18? 9 and 2. And we want them to add up to negative 11 and multiply to positive 18, so it's going to be a minus and a minus. Okay, and you don't have to write this down, but again, if we check the inside and check the outside, they should add up to the middle term. And then the very last one is still smiley face method, except for we're just going to do this with when there's a number in front. Like it's 2x squared, not just x squared. So what multiplies to 2x squared? 2x times x. What multiplies to 21? Okay, so you got to just think of numbers that go to 21. So we could do 7 times 3 or 21 times 1. And we could do 7 first, 3 second, or we could do 3 first and 7 second. In this case, we're going to put the 7 second and the 3 first. And I'll show you why. We're going to check our work. The inside is positive 3x. The outside is positive 14x. When you add those up, you get 17. So that's why the numbers had to go in that order. And so those are the ones that we already covered. The new method is called sum and difference of cubes. Whenever we have a perfect cube times a perfect cube, like 8x cubed plus 27, those are both perfect cubes. And the reason why is 27 is equal to 3 times 3 times 3, that's why it's a perfect cube. So what we're going to do in the binomial is we are going to cube root both terms and put in the binomial. So the binomial is that first group of parentheses. It's got two things, so it's called a binomial. So what we did there is basically we took the cube root of 8x to the third and got 2x. And we took the cube root of 27 and got 3. Again, it's 3 because of what we set up here. So that's how we got the 2x and the 3, because we took the cube root of both of them. In the second set of parentheses, which is the trinomial, 3 terms, the first term is take first term in binomial squared. So you take the first term, which would be 2x, and you square it. So 2x times 2x is 4x squared. The middle term is multiply terms from binomial. So the terms in the binomial are 2x and 3. 2x times 3 is 6x. And the last term is take second term, and I'll put from binomial, and you square it. So in this case, it would be 3 squared. Okay? And how the symbols work is same, opposite, plus. So what I mean by that is if you look, in this problem, it's a minus sign, and they're both perfect cubes. So the same sign is minus, the opposite sign is a plus, and the last sign is always a plus. If you look above, there's a plus sign. The same as a plus sign will be another plus sign. The opposite of a plus sign will be a minus, and then the last sign is always a plus. So when you do your factoring for sum and difference of cubes, it's always going to be same sign, opposite sign, plus sign. Okay, we have a couple examples below we're going to do together. So number 1, y to the third and 125 are both perfect cubes. Okay, 125 is 5 times 5 times 5, and y to the third is y times y times y. So what we do is we take the cube root of each of these. The cube root of y and the cube root of 125. Sorry, cube root of y to the third and the cube root of 125. We get 5 and we get y. So I like to think of it as set up your parentheses. I'm going to fill in the parentheses and then put the symbols in. So in the first parenthesis is you put the cube roots. So y will come first, 5 will come second. Okay, we got to be careful we do put them in the right order, because if 125 came second, the cube root of 125 should come second. In the second parenthesis, there's 3 terms. It's a trinomial. The first term is your first term from your binomial squared. So you take y squared. The middle term is the two things from the binomial multiplied together. So it's y times 5. And the last term is the second term of your binomial squared. And the symbols we use are same, opposite, plus. So same would be a minus sign. The opposite of a minus is a plus sign. And the last sign is always a plus sign. So if we do some simplifying, our answer will be y minus 5 times y squared plus 5y plus 25. And that will be our answer. That's called the difference of cubes because they're two perfect cubes. In number 2, 16u to the third plus 54. The first step we always check for is a GCF. In this case, the GCF is 2. Divide them both by 2, and we end up with 2 times 8u to the third plus 27. Okay, and then from here, we got to check the parentheses. The parentheses actually have two perfect cubes. 8u to the third is a perfect cube, and so is 27. So we're going to take the cube root of 8u to the third, and we will get 2u. And we're going to take the cube root of 27 and get 3. Again, since both of these are perfect cubes, and the hint I would give you is look at the exponent. If the exponent's a third power, it's probably going to check for perfect cubes. Once you find the cube root, we got to follow our steps again. So first set of parentheses is a binomial. The second set is a trinomial, so I always make that second set bigger. 2u will come first, and 3 will come second. In the second parentheses, we take 2u and we square it. The middle parenthesis is 2u times 3. You multiply them together. And the last parenthesis is you take 3 and you square it. Okay, and the symbols are going to be same, opposite, plus. Erase this. So the same symbol would mean keep it a plus sign. The opposite of plus is minus, and the last sign is always a plus. So we rewrite this, it's 2u plus 3, and then 2u squared is really 2 squared, which is 4, and then u squared. Minus 6u plus 3 squared, which is 9, and you have to bring down your GCF because that stays with it. And that would be how you factor with a GCF and then do a sum of cubes. Sum of cubes is what it's called because it's a plus sign. Right. The next one we've actually covered a little bit this year called grouping. And this occurs when there's 4 terms. So what you do here is you group the first 2 and you group the second 2, which is why it's called grouping. And you take out a GCF from both of them. So the GCF for the first 2 is x squared. The GCF for the second 2 is 9. And then we factor out the GCF. So we end up with x plus 2. The second GCF was a positive 9, and we end up with x plus 2. And now you'll notice that the parentheses are the same. And if you remember earlier this year, that's what should happen. So we take that, whatever is the same in the parentheses, and put it first. Bring it out front. And the leftovers come second. So this would be our answer for how we do grouping. And again, that happens when there's 4 terms. So we check this. Number 1, 4 terms, so we do grouping. The GCF for the first 2 terms is x squared, so x squared, and the leftovers will be x plus 3 because you took away 2 x's. The second GCF is going to be a positive 10, and the leftovers are going to be x plus 3. again, you will notice the parentheses are the same. So you bring out the common parenthesis, which is x plus 3, and the leftovers are x squared plus 10. And we have one more grouping one. There are 4 terms, 1, 2, 3, 4, and there's no GCF, so we're going to end up doing grouping for this one as well. So group them together and take out the GCF for the first 2. So the only thing those 2 have in common is they both have an x squared. So if I take away an x squared, we end up with y squared minus 3. The second 2, the negative 4y squared and the plus 12, can both be divided by negative 4. And the reason I picked a negative 4 is because when there's a negative, I'm going to take out a negative GCF. And that's just how it usually works for these. If I take out a negative 4, I end up with a positive y squared, and positive 12 divided by negative 4 is a negative 3. So do you see that I ended up with the same thing now? If I took out a positive 4 as my GCF, I would have had a positive 3, and they wouldn't have been the same. So you take out the common parenthesis, the y squared minus 3, and then we put in the leftovers, x squared minus 4. And we are not quite done because this second parenthesis is actually 2 perfect squares. X squared is x times x. 4 is 2 times 2, and we're going to put a plus sign and a minus sign. So this one actually had another step of factoring. We had to factor out a difference of squares at the end, and that will be our answer. Okay, so most of the stuff we covered, the grouping, the GCF, all that stuff should be reviewed. The sum and difference of cubes is what's new. There's one more sort of new thing I'm going to show you. We call it quadratic form, and it's when we have big exponents. Like if you look here, we have x to the 6th, x to the 4th. Those are big exponents. So what we do for this one is we're going to write these as squared terms. Okay. So like down here, we have 2 perfect squares. So how I would rewrite this is the square root of 49 is 7. And if we take x to the 6th and break it into 2 groups, those groups would be x to the 3rd. So this is really 7x to the 3rd squared minus 11 squared. Now we have a difference of 2 perfect squares. So if we do difference of squares, this would be 7x to the 3rd. And the second part would be 11, and we have a plus sign and a minus sign. Because now 7x to the 3rd, if I were to FOIL, 7x to the 3rd times 7x to the 3rd is 49x to the 6th. 11 times negative 11 is negative 121. So we end up writing those as squared terms and then doing a difference of squares. Okay, this second one, there's a couple ways we could do it. The one way I will show you is we can do substitution. So what that means is, since we have an x to the 4th and the middle is x squared, that middle term we're going to do is say x squared equals w. That's what we're going to say there. And then if I square each of these, that means x to the 4th equals w squared. So we're going to replace the x squared with a w and the x to the 4th with w squared. It's called substitution, and actually those of you that go on to pre-calc and calculus would do it a lot. So this would be, instead of x to the 4th, it's w squared minus 7 times x squared. Instead of x squared, we're going to say 7 times w minus 18. Now, we will factor this using a smiley face, W times W. We're going to have negative 9 and positive 2. Because negative 9 times positive 2 is negative 18, and negative 9 plus 2 is negative 7. The last step is, do you see where those W's are? We're going to replace the W with an x squared. So now we have x squared minus 9 and x squared plus 2. So we had to go back and replace the W with x squared. And the very last thing is, this is a long process, I know, x squared minus 9 can be factored again, because now we have a difference of squares. X times x, 3 times 3, and a plus and a minus sign. Okay. That substitution stuff can be kind of tricky, so I know I showed a couple different ways. When we run into the problems like this in class and we practice them, you'll probably see me explain a couple different ways, but that's the way we'll show it for right now. Good luck, and come see me if you have questions.